Shear force and bending moment diagram. This is the second video. In this video, simply supported beam with point load only are considered. This is the beam. Find the reaction RA and RB for the following beam and draw shear force and bending moment diagram. Let us see the beam. This is a simply supported beam with point load 17 Newton and 20 Newton at distance of 2 meter. Now let us give the name. This is A, first support A, second support is B. 17 Newton force is acting at C and 20 Newton is acting at point D. We will first find out the beam reaction RA and RB. To find out the reaction RB, we will take moment of all the forces about this point A. Now this is a reaction RA. Its moment about A will be 0. And the sign convention which we will use here is clockwise positive and anti-clockwise negative. How we calculate the reaction RB? RB is equal to, the first force is 17 Newton. Its distance from A is 2 meter. So 17 into 2 is the moment of this 17 Newton force about point A. So 17 into 2, and right hand side going down is positive. So this going downward force will give clockwise moment and it is taken as positive here. The second force is 20 Newton. It is at a distance of 4 meter from A, 2 plus 2. So from A to D the distance is 4 meter. So the moment about A for this 20 Newton will be 20 into 4. Again this is going downward will be positive. So plus 20 into 4. Now these are the two forces. Put it in the bracket. Bracket open, 17 into 2 plus 20 into 4, bracket close, divide by the distance between A and B, and that distance is 6. So take the calculators in your hand and do the calculations. Bracket open, 17 into 2 plus 20 into 4, bracket close, divided by 6. You will get this answer is equal to, plus is equal to, you will get this answer RB is equal to 19 Newton. Then let us calculate RA. How we calculate RA? RA will be equal to, now the sign convention is we take going down as positive and going up as negative. Summation of all the vertical forces. RA will be equal to, now going down 17 and 20 going down, so 17 plus 20, and RB is going up, so it is minus. 17 plus 20 minus RB, substitute the value of RB from here, 19. Do the calculations, take the calculators in your hand. 17 plus 20 minus 19 is equal to, you will get RA 18. In the exam only these steps are expected. Then write here the reaction RA 18 and here RB 19. So let us write that RA is 18 and RB is 19. Then we draw the shear force diagram. How we draw the shear force diagram? Let us take our baseline first. Now this is my baseline. We will start always from the left hand support. Now at the left hand there is A, and this RA is going up and it is 18 Newton. So from this point we will go up by 18 Newton. So a vertical line I will draw here, a straight vertical line of 18 Newton. So this is my vertical line and its magnitude is 18 Newton. So this is 18 Newton. Now A to C there is no force. So the shear force will be 18 Newton. So I will draw a horizontal line of 18 Newton from A to C. So this is a horizontal line from A to C, and everywhere here the shear force from A to C anywhere is 18 Newton. Now at C the 17 Newton force is going down. So at C here we go down by 17. So here I am at plus 18 and go down means this is minus, we will take it as minus. So 18 minus 17. So this is my 17. I'm coming down here vertically by 17. So this is 17 which is equal to this force which is at C. So what remains here is this is plus 18 and this is minus 17. So here the balance is 1. So this is 1 Newton here. Now from C to D there is no force. So this horizontal line of 1 Newton will continue here. So I draw a horizontal line of 1 Newton. This is my horizontal line of 1 Newton from C to D. Everywhere here the shear force is 1 Newton from C to D. Now here I am at 1 Newton. Now here a 20 Newton force is going down vertically. So here I have to go down by 20. So this is, here I am at plus 1 and this is minus 20. So from here to this baseline 0 is 1 Newton. Below 1 Newton I will have to go down by 19. So total from this point I have to go down by 20 Newton vertically down. Now this is the vertical line. This is from here to here I have come by 1 Newton, and now here to here this is my 19 Newton. From below 0 here I have come down by 19 Newton. So from this point up to this point total I have come down by 20 Newton. Here at D the force is 20 Newton. So from this point I want to come down by 20 Newton. From here to here when I come by 1 Newton I reach 0. Below 0 I have come here by 19 Newton. From D to B there is no force. So this line of minus 19 will continue. So this horizontal line of minus 19, this is continued. When I am below this baseline, this blue baseline, this is a 0 line. Below baseline means this is minus. Now RB is 19 and it is going up. So from here I have to go up by 19, vertically up. So when I go vertically up by 19, this is minus 19 and this is plus 19. So here I reach the 0 baseline. And always remember that at the end for the shear force diagram we must reach this 0 baseline. Then our drawing is correct. Suppose if I get this ordinate by mistake as 18 and when I add this 19, here I come up by 1 Newton, that means it is wrong. I have done some mistake. Or here if I get instead of 19 here if I get a figure 20 and here I have to go up by 19. So 1 Newton here will be balanced. I will reach only 20 minus 19 means minus 1. So here some minus 1 or plus 1 or some other figure if I get other than 0, it means I have done a mistake in the shear force diagram. We must reach at the end at this base. Now what are the shear force calculations we can write? So shear force calculation, shear force at A, here this vertical line, this is the shear force at A and that is plus 18. So from here up to left of C, up to here, the shear force to the left of C is 18 Newton. Now at right, here at right what happens is we come down by 17. So 18 minus 17, this is 1 Newton. So at right of C, this is 1 Newton. From here to the left of D, this 1 Newton. So shear force at D left is 1 Newton. At D again this is 20 Newton force going down. So 1 minus 20, that is minus 19. So at the right of D is minus 19 here, and at the left of D this is 1 Newton. So shear force D left is 1 Newton, shear force D right is 1 minus 19, that is minus 19. Now here this 19 continues. So shear force at B, if I see, this is minus 19. Shear force at B is minus 19. And the check, this is minus 19 and here I go up by 19. So here I reach 0. So minus 19 plus 19, 0. This we must get the check at the end. We must reach 0. So this is the shear force diagram. Now let us see how we draw the bending moment diagram. For the bending moment diagram, let us first do the bending moment calculation. Now this is a simply supported beam. So at A and B simple support, bending moment is 0. At C, how much is the bending moment? What I do is I consider the left hand side. So when I consider the left hand side, there is only one force, 18 Newton, and I take moment about point C. So this moment of RA about point C will be 18 into this distance 2 meter. So 18 into 2 is 36. Here I am writing bending moment at C is 18 into 2, 36 Newton meter. Similarly, I want bending moment at D. Now bending moment at D will be, I consider now the right hand side of the section, and this is 19 Newton. So the bending moment will be 19 into 2. Bending moment at D for this RB 19 Newton will be this 19 into this distance between this 19 Newton and point D, that is 2 meter. So bending moment at D is 19 into 2, 38 Newton meter. The sign convention is, if the force is going up, it is positive. Now RA is also going up, RB is also going up. So bending moment at C and D both are positive, because 18 is also going up and 19 is also going up. So the bending moment is positive. Now how we draw the bending moment diagram? First let us take the baseline. This is my baseline. Bending moment at B here and at A is 0. Now bending moment at C is 36 Newton meter. So this is my C here. Here I draw a point. This is a 36. So now this is a point of 36 Newton meter. Now A to C there is no force. So it will be a inclined straight line. Bending moment is an inclined straight line. So I just join this point of 0 and this point of 36. So this is the bending moment diagram. Now here again bending moment is 0 and bending moment at D is 38. So this is my point D here. In this straight line I come down, this is D, and I take a here point of 38 Newton meter. This is my point 38 Newton meter. Now this point and this D I join with inclined straight line, because here there is no force. So inclined straight line. Again C to D no force. So this point of 36 and 38 join with a straight line. So this is an inclined straight line, and this completes the bending moment diagram. Now I write the name. In the exam you must give the name to your diagram. So this is the shear force diagram. Then this is the bending moment diagram. Now when we are above baseline, the bending moment shear force here is taken as positive. When I am here below the baseline, then this shear force is negative. Here everywhere we are above the baseline, so this bending moment is positive. This completes the shear force and bending moment diagram for the given beam. Let us take a second problem. Again the question is same. Find the beam reaction RA and RB for the following beam and draw shear force and bending moment diagram. Now let us see what is the beam. Now I have kept the same beam, only thing is here I have changed the forces. Now A and B are simply supported, distance is 2 meter, 2 meter, 2 meter, and at C now the force is 16 Newton going downward. At D the force is 22 Newton going downward. What we have to first do is calculate the reaction RA and RB. Now let us calculate the reaction RB. To calculate this reaction RB, we take the moment about point A and we consider clockwise as positive. If right hand side is going down, so this 16 and 22 will give us clockwise movement about A. So how we get RB is equal to, RB is equal to now 16 into distance from A to this 16 Newton force, that is 2 meters. So 16 into 2. For this 22 Newton force is distance from A is 4 meter. So 22 into 4. 16 into 2 plus 22 into 4. And put this in bracket and divide by the distance between A and B, that is 6. So write it like this. Bracket open, 16 into 2 plus 22 into 4, bracket close, divided by 6. Take the calculators in your hand and do the calculations. Bracket open, 16 into 2 plus 22 into 4, bracket close, divided by 6 is equal to, you will get the answer 20 Newton. Now how we calculate RA? For RA the sign convention is going down positive, going up negative. Now RA is equal to, going down 16 and 22 going down, so 16 and 22 positive, RB going up negative, minus RB. Substitute the value of RB from here. So 16 plus 22 minus 20. So take the calculators in your hand and do the calculations. 16 plus 22 minus 20 is equal to, you will get the answer Ra is equal to 18 Newton. Now write the Ra Rb here. Let us show the reactions. At A it is 18 Newton, so here 18 Newton. At B Rb here, Rb is equal to 20 Newton. This is how we calculate the beam reactions. Only these many steps are sufficient to calculate the beam reactions. Now let us draw the shear force diagram. Let us take the baseline. This is my baseline. Now Ra 18 Newton is going up, and we will always draw the shear force diagram from the left only. And for the left, the sign convention is if the shear force is going up, we take it as positive, and if the shear force, if the force is going down, we take it as negative. So here Ra going up, so we will go up here by 18 plus 18. So this is the line, this is 18 Newton, a vertical line of 18 Newton from here to here. Now A to C no force, so I will continue this horizontal line of 18 Newton. So this is continued up to C. Now here at C of the force 16 Newton is going down, so from here we will go down by 16. Now here I am at plus 18 and I do minus 16, so when I come down here by 16, the balance remaining will be 2 Newton. So this is 16 and the balance here is 2 Newton. So 16 plus 2, this is 18. Now C to D, this 2 Newton horizontal line will continue because there is no other force. So this horizontal line of 2 Newton from C to D is continued. Now here at D I am at plus 2 Newton. Here the force is 22 Newton. So from this point I have to go down by 22. So when I go down by 2, I reach 0. Below 0 I have to go by 20. So this is plus 2 and this is minus 22. 2 minus 22 will be minus 20. So this is 2 Newton above baseline and 20 Newton below baseline. Total from this point to this point I have come down by 22. 2 plus 20 is 22. 2 Newton is above baseline and 20 Newton below baseline. So this is minus 20. Here I am at minus 20. Due to be no force, so this minus 20 horizontal line we will continue. So this is minus 20 up to point B. At B there is a 20 Newton force going up. So from this point I will go up by 20. When I go up by 20, I reach 0. This is minus 20 here and this is plus 20. So minus 20 plus 20, I reach here 0. And I must reach here at 0. Then only my shear force diagram is correct. And this vertical ordinate is 20 Newton. Now how we write the shear force calculation? Shear force calculation. Shear force at A. Now here this vertical line, this is plus 18. So shear force at A is 18. From here to here up to C left, this is 18 only. So shear force at C left 18. Then we come down by 16. So 18 minus 16 is 2 Newton. So shear force here at C right is 2 Newton. This continues up to D left. So shear force at D left is 2 Newton. And here this is 22. So we come down by 22. So 2 minus 22. So shear force at D right is minus 20. So here you can see that shear force at D right is minus 20. Shear force at B is, this is minus 20. Here we can see this vertical ordinate, it is below baseline and it is 20 Newton. So shear force at B is minus 20. And the check is, this is minus 20 and here we go up by plus 20. So minus 20 plus 20, here we reach 0. So this is the check which we give to the shear force. Now let us come to bending moment. How we do the bending moment calculations? Bending moment at A and B is a simply supported. So at A and B bending moment is 0. Bending moment at C, when I want to calculate, I consider the left hand side. So when I consider the left hand side, there is only one force, Ra 18 Newton. Its moment about C will be 18 into this distance 2 meter. So 18 into 2, 36 Newton meter, which I have shown here. Bending moment at C, 18 into 2, 16 Newton meter. 18 Newton is going up, so this is a positive bending moment. Then I want bending moment at D. At D, when I want bending moment, I consider the right hand side of the beam. then it is, this force is 20 into distance is 2 meters, so 20 into 2, 20 into 2, 40 Newton meter. Again this 20 force is going up, and so this is positive. While doing the bending moment calculations, the sign convention says if the force is going up, bending moment is positive. Now how we draw the diagram. This is our baseline. At A here bending moment is 0, at C it is 36. So this is my point C. Vertically I come down here, and here I make a point of 36. This is my point of 36 Newton meter. Then I join this point A and point C with an inclined straight line. This is, then bending moment at B is 0, and at D it is 40. Here at B it is 0, and at D, this is straight down, at D I make a point of 40. So this is my point of 40 Newton meter, and I join this 40 Newton meter and this 0 with inclined straight line, and then I join this 36 and 40, because here in between there is no UDL and nothing, no force, so it will be inclined straight line from here to here. So another inclined straight line. This completes my bending moment diagram. This is how we draw the bending moment diagram. Let us give the name shear force diagram, bending moment diagram. Now the shear force here up to this point D, here A to D shear force is positive. We are above the baseline, and from D to B, this here the shear force diagram is negative, and bending moment diagram full from A to D is positive. This completes the shear force and bending moment diagram for this problem. Let us take a next problem. Now this is the beam. Here I have increased the forces. Now there are 3 forces. This is a 12 Newton force at C, and at E 10 Newton force, and at D 15 Newton force. A and B is simply supported. So this force I have added the third force here at the center of the AB. And now we want to find out first the reaction RA and RB, and then we will draw the shear force and bending moment diagram. Now how to calculate RB? To calculate RB, we take moment of all the forces about point A. Moment of RA about A is 0. Then I will be taking moment of all these 3 forces. How we take it? Now these 3 forces, all of them going acting downward and right hand side, they will give clockwise moment, so it is positive. RB is equal to bracket open 12 into its distance from A is 2 meters, so 12 into 2. For this 10 Newton, now the distance from A, from this 10 Newton to A, it will be 2 plus 1, that is 3, so 10 into 3. For this 15 Newton, now its distance from A is 4 meter, 2 plus 1 plus 1, so it is 4 meter, so 15 into 4. Now I have completed all the forces, and RB is here, and put this into bracket, divide by the distance between A and B, that is 6. So write it like this, then take the calculators in your hand and do the calculations. Bracket open, 12 into 2 plus 10 into 3 plus 15 into 4, bracket close, divided by 6 is equal to, you will get the answer 19 Newton. Now let us calculate RA. The sign convention is going down positive and going up negative. So RA is equal to going down 10, 12, 10, 15. So all of them are positive. 12 plus 10 plus 15. RB going up, so minus RB. Substitute the value of RB from here, 19. Then do the calculations. Take the calculators in your hand. 12 plus 10 plus 15 minus 19 is equal to, you will get the answer 18 Newton. So let us show the RA/RB here in the figure. This is RA 18 Newton, and here RB 19 Newton. Now let us draw the bending moment diagram. Now this is my baseline. Now bending moment, shear force diagram. Now this is the baseline for the shear force diagram. We will start from the left as usual. At RA it is 18, so here I will go up by 18 Newton vertically up. This is my 18 Newton. A to C no force, so horizontal line of 18 Newton. At C, here I will have to come down by 12, so come down by 12. 18 minus 12, that is 6, so this is 12 Newton, and this horizontal line of 6 Newton I'll continue from C to E because there is no force. At C, at E now I am C to E, this is 6. At E I have to go down by 10. Here to here I will go down by 6, and 6 minus 10 is 4, so minus 4, so below baseline minus 4. I'll show it here. Above baseline it is 6, below baseline 4. So here to from this point to this point I have come down by 10 Newton. So from here up to baseline we are coming down by 6, below baseline we are coming by 4. So here we are at minus 4. E to D no force, continue the horizontal line of minus 4. At D we have to go down by 15, so here I'll come down by minus 15, vertical line of minus 15. So this is a minus 15 and this ordinate is 15. So here I am at minus 4, minus 15. So minus 4 minus 15 means here I have reached at minus 19. Now I'll D to B there is no force, so this minus 19 line we will continue, horizontal line of minus 19. Here I am at minus 19. Now at B 19 Newton force is going up, so we will go up from here to here by plus 19. So this is minus 19 plus 19 means we will reach here 0. This 15 plus 4 is 19. So from here to here when I go up by 19 I reach 0. This is 19. So here I have reached 0 means shear force diagram is correct. Let us see the shear force calculation. Shear force at A. At A this is plus 18. Shear force at A is plus 18. This 18 continues up to the left of C. So shear force at left of C is 18 Newton. Shear force at right of C is plus 6. So shear force at right will be 18 and this minus 12. So 18 minus 12 is 6 Newton. This 6 Newton will continue up to the left of E. So shear force E left is 6 Newton. Shear force E right we come down by 10. So 6 minus 10 is minus 4. So shear force at E right is minus 4. Here we can see shear force at E right is plus 6 and shear force at E left is plus 6 and shear force at E right is minus 4. This minus 4 continues up to D left here. So shear force at D left is minus 4 and shear force at D right will be minus 4 minus 15, that is minus 19. Here it is 15 going down, so from here minus 4 we again come down by minus 15. So 4 plus 15, this is minus 19 at D right. This continues up to here B. So shear force at B is minus 19 Newton and the check is this is minus 19 and this RB plus 19. So minus 19 plus 19, here we reach 0. That is a check. Okay, then let us do the bending moment calculations. This is a shear force diagram. Now here bending moment at A is 0 and bending moment at C will be, if I consider the left hand side, it will be 18 into 2. So this is my ordinate of 36 and I join this point 36 and A here and I get the bending moment as this is 36. Then bending moment at D, B is 0 and bending moment at D here. This is 19 into 2, that is 38. So bending moment here is 38 and bending moment here will be, if I consider this, take a section at E to calculate this bending moment at E, it will be if I consider the left hand side, it is 18 into this distance is 3, this is going up, 18 into 3 plus minus, this is going down, so it will be now minus 12 into 1. 18 into 3 minus 12 into 1. How much you get? You will get it as 42. Or if you do the calculation considering the right hand side here, it will be 19 into this distance 3 minus 15 into 1. You will again get 42. Here I am giving the bending moment calculations. These are the bending moment calculations. Bending moment at A is 0, B is 0. Bending moment at C is 18 into 2. Here this is 18 into 2, that is bending moment at C, that is 36, which I have shown here. Bending moment at D is 19 into 2, so this is 19 into this distance 2 meter, 19 into 2 38. And bending moment at E is, from here if I consider the left hand side, it is 18 into 3 minus 12 into 1, that is 42. And that is this bending moment at E here, which I have shown 42. And there is no UDL, so join these points with inclined straight line, and that gives us the bending moment diagram. Because there is no UDL, so everywhere it will be an inclined straight line. This is a bending moment diagram. Shear force diagram up to point E here is positive, A to E, and E to B here it is negative. And bending moment diagram full from A to B is positive. So this completes the shear force and bending moment diagram for this beam. Let us see now the next beam. Now this is the next beam. Now this is the beam simply supported at A and B, and again there are 3-point loads. Now the forces are different. At C it is 10, at E it is 12, and at D it is 13. Now let us first calculate the RB, and to calculate RB we take moment about point A, and clockwise, that is this going down, all these three forces will have positive moment about point A. Right hand side going down positive and clockwise. So RB is equal to 10 into its distance from A, 2 meter, 10 into 2, 12 into its distance from A, now 3 meters, so 12 into 3, 13 into its distance from A is 4 meter, so 13 into 4, this is 1 plus 1 plus 2, that is 4 meter, so 13 into 4. Put this whole thing in bracket and divide by the distance between A and B, that is 6 meter. So this is the equation to calculate RB. Take the calculators in your hand and do the calculations. Bracket open. 10 into 2 plus 12 into 3 plus 13 into 4, bracket close, divide by 6 is equal to, you will get RB is equal to 18 Newton. Then RA is equal to, RA will be equal to, now going down positive and going up negative, so all these 3, 10, 12 and 13 positive and RB negative. 10 plus 12 plus 13 minus RB, substitute value of RB from here 18. Take the calculators in your hand and do the calculations. 10 plus 12 plus 13 minus 18, you will get the answer 17 Newton. Now let us show RA and RB here. RA, this is RA 17, then RB, this is RB 18. Now let us draw the shear force diagram. Take the baseline. So this is my baseline. At A, we'll start from the left. At A, RA going up by 17. So from here go vertically up by 17. So this is my 17. A to C no force. So plus 17, horizontal line continued up to C. At C it is 10. So come down by 10. So I have come down by 10. So 17 minus 10. Here the balance is 7. So C to E, no other force, so this 7 Newton line will be continued. At E we have to come down by 12. Here I am at 7, so 7 minus 12, that is minus 5. So from here to here is 7, and below 7 I will go by 5. So this is 7 Newton, and below 7 below the baseline again go by 5 Newton. So 7 plus 5 is 12. So total from this point to this point I have come down by 12. Now I am here at minus 5. This is plus 7 and minus 12, that gives me minus 5. So when I come down here, from here I come down by 7, I reach 0, again I come down by 5, so minus 5, that is from this point to this point, come down by 12, which is the force at E here. Now from E to D no force, so continue the line of minus 5. So this is the minus 5 line is continued up to point D. At D come down by 13, so this is minus 5, and again minus 13, come down by minus 13. So this is my 13 Newton. D to B no force, so continue this line. Now from here to here I have come down by 5, again here I have come down by 13. Minus 5 minus 13 means I am here at minus 18, and I continue this horizontal line of minus 18. Now here RB is plus 18, so from here go up by 18 and we reach 0. So this is 18. 13 plus 5 is 18. So here we have reached 0, means our shear force diagram is correct. Now shear force calculations. Now at A here the shear force is plus 17. At C left it is plus 17. At C right this is 17 minus 10, that is 7. So here at C right is this ordinate is 7. At E left it is 7. So E shear force at E left is 7, and at E right it will be 7 minus this 12, 7 minus 12 minus 5. So E right here this is minus 5, and this is continued up to D left. So shear force at D left is minus 5. Shear force at D right is minus 5 minus this 13. Again we come down here by 13. So minus 5 minus 13, that is minus 18. So shear force here at D right, this ordinate is minus 18. This is continued up to B, so shear force at B is minus 18, and there is a check here. Here RB is going up by 18, so from here we go up by 18 and we reach 0. So minus 18 plus 18, 0. But we are not going to write that shear force at B is 0. Shear force at B is this ordinate, which is minus 18. So this is shear force at B is minus 18, and if shear force at A is asked, here we go up. So this is plus 17. Shear force at A is plus 17 and shear force at B is minus 18. This completes the shear force diagram. Now let us come to the bending moment diagram. Let us first do the bending moment calculations. Bending moment at A and B is simply supported, so bending moment at AB is 0. Bending moment at C, when I want a bending moment at C, consider the left hand side. When we consider the left hand side, it is 17 into 2. There on the left hand side there is only one force, 17. Take its moment about point C. So 17 into this distance 2, 17 into 2, 34. This 17 Newton force RA going up, so positive. Then bending moment at D, when I want, I consider the right hand side, and when I consider the right hand side there is only one force, RB going up, so 18 into its distance from D is 2 meter. So 18 into 2 going up positive, 18 into 2 36 Newton meter and positive. When I want a bending moment at E, suppose I consider the left hand side. Now there are two forces, RA and this 10, and I want to take the moment about E. So 17 into its distance from E is 3. 17 into 3, that is 17 into 3. Bending moment at E, 17 into 3 and going up, 17 going up, so positive. Another force is 10 Newton. So 10 into 1, its distance of 10 Newton force from E is 1 meter. So 10 into 1. Now this is going down, so it is minus. So minus 10 into 1. That will give me the bending moment at E. 17, do the calculations. 17 into 3 minus 10 into 1, it will give you 41 Newton meter. If I consider the right hand side, here right hand side there are two forces, 18 and 13. How we do it? 18 into its distance from E is 3 meters. So 18 into 3 going up, so positive. 18 into 3 bending moment is positive, and this is 13 going down, and its distance from E is 1 meter. So minus 13 into 1. Minus 13 into 1 is equal to, do this calculation, you will get the same answer, 41. If you are getting a different answer, it means you have done some mistake. You do, even if you consider the left hand side or you consider the right hand side, you must get the same answer for the bending moment at E, and that is 41 Newton meter. Now let us draw the bending moment diagram. How we draw it? Take the baseline. This is my baseline. Bending moment at A is 0, bending moment at C is 34. Here it is 0 and here at C it is 34. So this is my 34 point and there is no UDL or nothing, so A to C inclined straight line. This is my bending moment. Now here at D bending moment, so at B here the bending moment is 0, at G the bending moment here is 36 at D. So here I take a point of 36. This is my 36 and join the point from D here to B. B is 0 and D is 36 and here it is inclined straight line. Now the bending moment at E is 41. So let us here at E we take a point of 41. So this is my 41 Newton meter bending moment. Then I join this point C to E inclined straight line and E to D another inclined straight line because there is no UDL or any other force. So inclined straight line. So this is an inclined straight line from C to E and this is from E to D, and this is the bending moment diagram. So because here there is no space, I am writing it here, bending moment diagram. Now bending moment from A to E, this is above baseline, so this is positive. From E to B, here this is negative. Bending moment diagram here is full positive. The shear force diagram from A to E is positive. From E to B, here this is negative. Bending moment diagram from A to B, full positive. This is how we draw the shear force and bending moment diagram and do the calculations for shear force and bending moment. Let us take one more problem. Now this is a problem here. Here what we are doing is this. Here at here this is A, B, C, D and E. At B 16 Newton force going down, at C 4 Newton is going up, at D 25 Newton is going down. Now here we want to first calculate the reaction RA, and now this point is called E, so RE. Now first I will find out the reaction RE, and for to calculate this reaction RE, let us take moment of all the forces about this point A. Now how we take a moment? If on the right hand side the force is going down, its moment is positive, and now this 4 is going up, so its moment will be negative. So let us see how we do it. RE is equal to, now 16 into distance is 2, 16 into 2 and it is going down, so positive. Now for 4 Newton force, 4 into its distance from A is 3, 2 plus 1, but now it is going up, so we must take here minus. This is something very important to understand. If this force on the right hand side goes up, its moment becomes anti-clockwise, so it is negative. So minus 4 into 3. For this 25, again it is 25 into distance from A is 4, 2 plus 1 plus 1, so 25 into 4, and this is going down, so positive, plus 25 into 4, and put it in the bracket, divide by the distance between A and E. Now the distance between the two supports A and E is 6, so divide by 6. So this is the equation. Take the calculators in your hand and do the calculations. Bracket open. 16 into 2 minus 4 into 3 plus 25 into 4 bracket close divided by 6 is equal to, you will get RE is equal to 20 Newton. Now to calculate RA, the sign convention is same. Forces going down positive, going up negative. Now 16 and 25 going down, so positive. 4 and RE going up negative. So 16 minus 4 plus 25 minus RE, that will give us RA. Substitute the value of RE here 20. So 16 minus 4 plus 25 minus 20. Do the calculations. Take the calculators in your hand. 16 minus 4 plus 25 minus 20 is equal to 17 Newton. This is RA. Write RA here 17 Newton. Write RE here 20 Newton. Now let us draw the shear force diagram. Let us take the baseline here. Start from the left. RA going up by 17. So here I will go up vertically up by 17. This is my 17 Newton vertical line. A to B no force, so continue the horizontal line of 17 Newton. At B it is 16, so I will come down by 16. So 17, this is plus, and minus 16, 17 minus 16 will be 1 Newton. So this is 16 Newton I have come down, and here this small ordinate is 1 Newton, and B to C no force, so this horizontal line of 1 Newton we will continue. So from B to C the shear force is 1 Newton from here to here. Here now at C, this 4 Newton force is going up, so from this 1 I go up by 4, so this is at plus 1 and plus 4, so total I have come up here to here 4 Newton. So from the baseline I am at 5 Newton. This is 1 plus this 4. So from this baseline up to this point is I am at plus 5 Newton. And C to D the shear force will be plus 5 Newton. This horizontal line will continue. At D this is 25. So I have to go down by 25. From here to here when I reach 0 it is 5 Newton. And below 5 I will go by 20. So here it is 5 and here 20, total 25. So let us draw over this is 5 Newton, and from here to here I have come by 5. So this is I am at plus 5. 5 minus 25 will be minus 20. So below 0 I must go vertically down by 20 Newton. So from this point to this point this is 4 plus 1, that is 5 Newton. So from here to here 5 Newton, and here to here 20 Newton. So from this point to this point vertically we have come down by 25 Newton. This is 5 and this is 20, so 5 plus 20 total 25. From this point to this point is 5, and from this point to this point is 20. Total is vertical line is 25 Newton. So from this point to here I have come down by 25 Newton. Now this minus 20 horizontal line will be continued from D to E. So this minus 20 horizontal line is continued up to here. Now here RE is going up by 20, so here go up by 20, vertically go up by 20 Newton. This is a 20 Newton ordinate, and we reach 0 at E. Now shear force calculations, let us see. Shear force calculations, shear force at A. Now at A the shear force is 17, here at A. Up to B left it is 17, at B right this becomes minus 16. So 17 minus 16 is 1 Newton. So here at B right is 1 Newton. It continues up to C left. So shear force at C left is 1 Newton. Shear force at C right 1. And now this is going up. So 1 plus 4, that is 5 Newton. So here from here to here at right C right is 5 Newton. This 5 Newton continues up to D left. So shear force at D left is 5 Newton. Shear force at D right, at D right from this 5 we come down by minus 25. So 5 minus 25, that is minus 20. So D right is, this is minus 20. This minus 20 is continued up to E. So shear force at E is minus 20. Here this ordinate is minus 20, and minus 20 plus RE going up, so go up, so we reach 0. Here we reach 0. But shear force at E is not said to be 0. Even though we reach here 0, shear force at E is this ordinate, that is minus 20, and shear force at A, here it is 0, but shear force at A is this vertical ordinate, that is plus 17. This completes the shear force diagram. Let us come to the bending moment. Bending moment calculations. Bending moment at A and E. Now E is simply supported, so at A and E bending moment is 0. Bending moment at B. When this is a point B, we consider only the left hand side. There is only one force on the left hand side, that is 17. Its distance from B is 2, so 17 into 2, that is 34, and RA going up, so plus. So bending moment at B is 17 into 2, that is 34 Newton meter, and this 17 is going up, so it is plus. Now then I want bending moment at C. Let us calculate bending moment at C here. If I consider the left hand side, there are two forces, this 17 and 16. So for this 17, the bending moment at C will be 17 into its distance from up to C is 3 meters. So 17 into 3 going up positive. 17 into 3 bending moment at C. 17 into 3, and the second force here is 16. It is going down, so minus 16, and the distance between B to C is 1. So 16 into 1. 17 into 3 minus 16 into 1. Do the calculations. 17 into 3 minus 16 into 1. You will get it plus 35 Newton meter. When I consider the left hand side, I have to consider these two forces. Now if I want bending moment at C and I take the right hand side, on the right hand side there is one force 20 and another is 25. How we will calculate it? 20 into, now this distance is 3, 20 into 3 going up positive, so 20 into 3 going up positive, and for this 25 into this distance is 1 meter from C, so 25 into 1 and going down, so minus 25 into 1. Do the calculations. 20 into 3 minus 25 into 1 is equal to, you will get the same answer, 35, and you must get the same answer in the exam. You can calculate it from left or from right, or any one answer is sufficient. Then bending moment at D. At D, when I want a bending moment, if I consider the left hand side, there are three forces, 17, 16 and 4. The calculations are very lengthy. So what we do is we consider the right hand side only, and on the right hand side there is only one force, 20, and its distance from D is 2 meter. So 20 into 2, that will give me the bending moment at D is 20 into 2, that is 40 Newton meter. Now how we draw the bending moment diagram? This is the baseline. Bending moment at A is 0 and at B it is 34. So let us first take the point 34. This is my bending moment at B, and it is, this ordinate is 34, and at A it is 0, at B it is 34, and join with an inclined straight line. Then let us come to the next, that is bending moment at D, it is 40. So this is my point of 40, and bending moment at D is 40, and at E it is, at E here it is 0. So from 0 to here will be a inclined straight line. This is 40 and this is an inclined straight line. Then bending moment at C is 35. So let us take that point. So this is my point of 35. This is point C, straight vertically come down. This is 35, and now from B to C inclined straight line, and from C to D again an inclined straight line, because there are no other forces. So join with inclined straight lines. This is the bending moment diagram. Give the name bending moment diagram. From A to D the shear force is positive. From D to E, here the shear force is negative. Bending moment from A to E is positive. From A to E full, the bending moment is positive. This is how we draw the bending moment and the shear force diagram. Now let us some standard case. Draw shear force and bending moment diagram for a simply supported beam with point load W at center and span L meter. So now this is a beam simply supported and the length is L meter. The central point load at L by 2, this is W. Now these are the support I'm calling AB, and the center is called C. Now first we calculate the beam reaction. How we take? Now to calculate RB, take moment of all the forces about A. So W and its moment about A will be W into L by 2, and divide by the distance between AB, that is L. So W into L by 2 divided by L, L gets cancelled, so RB will be W by 2. How you calculate RA? RA will be W minus RB. W and RB going up, so minus, substitute value of RB, W minus W by 2, that gives us W by 2. So reaction at RA and RB both are W by 2. Let us show it here. RA is equal to W by 2, and here RB is equal to W by 2. This is the beam reaction. This is a standard case. Now let us draw the shear force diagram. Let us take the baseline. At A, the shear force going up is W by 2. So here I go up by W by 2, vertically up by W by 2. A to C no force, so continue the line of W by 2. Here I have to come down by W. I come down up to here by W by 2. So W total I have to come by W. So W minus W by 2. This is From here to here I come down by W by here to here W by 2, and again below 0 W by 2. So W by 2 plus W by 2, total I come down by W. This is from here to here W by 2, and again here to here minus W by 2. From this point to this point W by 2 plus W by 2, that is total W ordinate. And this minus W by 2 line will continue here up to B. At B it is plus W by 2. So from here go up by W by 2 and you reach 0. This ordinate is W by 2. This is how you draw the shear force diagram. This is a standard shear force diagram, and you must remember it. Shear force calculations. Now shear force at A here is W by 2. At left of C it is plus W by 2. At right it is here it is plus W by 2 and minus W. W by 2 minus W will be minus W by 2. So here shear force at C right is minus W by 2. Continue here up to B. So shear force at B is minus W by 2, and check minus W by 2 and this plus W by 2. Here it becomes, we reach here 0. This, then let us do the bending moment diagram. How we get it? The bending moment at A and C, B, simple support, so 0, and bending moment at C will be, now on the left hand side if I consider this is W by 2 into L by 2, so WL by 4. Bending moment at A is 0, bending moment at B is 0, bending moment at C, this force is W by 2 and distance is L by 2. W by 2 into L by 2, that will be WL by 4. 2 into 2 is 4. So here the vertical ordinate will be at center C. Here will be WL by 4. So this is my ordinate WL by 4. A to C inclined straight line, and again this is B to C is another straight line. So this is how we get the bending moment diagram. This bending moment diagram and shear force diagram, this is a standard case, and you need it for other chapters like bending stress, shear stress. You need these figures, so do it properly. Remember the shear force and the bending moment diagram and its ordinates. Bending moment from A to C, here this is shear force from A to C, this is positive. From C to B, this is shear force is negative. Bending moment from A to B, full positive. This completes the shear force bending moment diagram for this figure. Let us take another case, that now draw the shear force and bending moment diagram for a simply supported beam with point load W Newton, not at center, and the span of the beam is L meter. Now this is the simply supported beam, L meter. Now W Newton force. Now W is acting at a distance of A, small a. This W is acting at a distance of small a from support A, and at a distance of small b from this support B. So this is the point load W which is acting at C. Now this C is not at center. How we do it? Let us calculate the beam reaction. Take moment of the force of all the forces about A to calculate RB. RB will be equal to, now this moment is W into A clockwise, so W into A divided by the distance between A and B, that is L. So WA divided by L, so RB is equal to WA by L. This RB is WA by L. How you remember it? When you want RB, take distance A. So RB is equal to W into A divided by L. RA will be equal to W going down positive, RB going up negative, W minus RB, substitute value of RB is WA by L. Here for that is W, multiply and divide by L. So W into L divided by L minus WA into L. Now take out W common. What remains in the bracket is W. If you take it out common, L minus A. This is L and here it is A, and divided by L. This divided by L is common. So this becomes in bracket L minus A. What is L minus A? If I do L minus A, I get B. So L minus A is B. So RA is equal to W into B divided by L. So when you want RA, multiply by B. When you want RB, multiply by A. So WA into L is RB and WB into L is RA. Now let us write it here. RA is WB into L, sorry, W into B divided by L, and RB is W into A divided by L. Now let us draw the shear force diagram. This is the baseline. At RA, the shear force is WB by L. So from here go up by WB by L. This is a vertical line here, and this ordinate is W into B divided by L. This horizontal line will continue up to point C. At C, we have to come down by W. So from here to here, we have to come down by W. When I come down by W, this vertical ordinate is WB by L. And when I do minus W, I get it here, WA by L. And this from here to here, if you add these two, what you get? You get W into bracket A plus B divided by L, and A plus B is L. So this vertical ordinate is W. L gets cancelled. Now from here I draw the horizontal line, WA by L. Here this is plus WA by L. So this is minus WA by L, and plus WA by L, we reach 0. This ordinate is WA by L. How we do the shear force calculation? Shear force at A, WB by L. This is WB divided by L. So WB by L, this is the shear force at A. Shear force at C left is same, WB by L, WB divided by L. Shear force at C right, WB divided by L minus W. Here for this W, divide and multiply by L. So WB by L minus WL divided by L. Now take out W and divided by L common and give a minus sign. So this is minus W. Now this is minus minus, which will become plus L, and this will be minus. So L minus B divided by L, and this is minus here. L minus B. Now L minus B will be A. So this is minus W. L minus B is A divided by L. This is WA by L. That is the shear force at C, right? Same will be at B here, minus WB by L, and the check minus WB by L, and this WA by L gets added, and it becomes, we reach here 0. So this is the shear force diagram if the point load W is not at center. What is the bending moment? Now let us do the bending moment calculation. Bending moment at A and B, it is simply supported, so A and B, bending moment is 0. Bending moment at C will be, no, bending moment at C, consider the left hand side, this force is WB by L into A. So WB by L into this distance is A. So WAB, this A into B. So WA into B divided by L. This is the bending moment at C. So let us show what is the bending moment at C here. That is WAB by L. At A it is 0, so join it with straight line. At B it is 0, join from here to here. So join AC, and this is AC I have joined, and then join BC, and this is the BC. B at B it is 0, at C it is WAB by L, and at A again it is 0. So this is the bending moment diagram, and this is this value WAB by L below the point load C. This is a standard case, and we need these standard figures for shear stress, bending stress calculations, etc. when we do the other chapters. So do it very seriously. Shear force from A to C, this is positive. Shear force from C to B, this is negative, and the bending moment diagram from A to B is positive. Be a master. Thank you.